Read the disclaimers. And please use common sense.
It has been 1 week since I set out to create a container for my metal cards, and at last I have achieved my original vision for the item. When you lift the lid, the gear gimmick lifts up the metal cards, and the end results are a mother... Salutations, denizens of the internet, and welcome to 3DDD, or 3D Design Diary, a series dedicated to showing off my progress on my 3D printer projects. Last week I showed off a design for a 3D printed Metal Cardbot metal card carrier, which I designed because as a Metal Cardbot collector, my metal card collection doesn't do anything except lie around all day, which is an unfortunate consequence of the fact that I like to display my metal card figures with their weapons equipped. You may also remember that the initial product was massively dumbed down from my initial idea, and the initial idea was to have the lid turn a series of gears that would elevate each of the individual cards so they'd be easier to pick up. But the dumbed down version did not work as intended. The cards rattled too much, and they could fall out of their slots within the container, unless it was the card in the backmost slot, which would just fall out of the container wholesale. My point is, there was obviously room for improvement, and I thought the best way to improve on all these problems was to revisit my original idea. And to say things looked incredibly promising at first would be a massive understatement. Sure, I had to print out several pieces multiple times and make small adjustments to each iteration of the parts, and I had to simplify the idea down from multiple slots moving up to just a ramp pushing all of the cards up at once from the bottom. It was relatively smooth sailing. Though maybe the first red flag we should have all seen coming is the fact that while I am used to making multi-part prints that rely on friction to hold together, I'm not as experienced with making moving parts. Not to mention, 3D printer plastic has this fun little quirk where any joints you make out of the stuff don't stay tight for very long. That's something I learned the hard way from my PowerCore combiner limbs, as weeks after printing them, they got super loose. Not to mention the total part count on this project became absolutely hateful. The previous record holder for the most complicated 3D print item I've ever made went to this sword, the Hands of Maladonis, coming in at a staggering 12 parts. Meanwhile, the carrying case has a right and left motherboard component, right and left card slot components, a lid component, two identical vertical movement gears, a back cover component, two pegs that affix the gear shaft to the back of the box, the component that lifts the cards, two pieces that attach to the wedge that pushes that part up, the aforementioned wedge that pushes up the part that pushes up the metal cards, two bolts that affix the lid to the motherboards, two identical pegs that affix the topmost gear to the motherboards, two pegs that affix the bottommost gear of the assembly to the motherboards, the two pegs that affix the second gear from the top to the motherboard assembly, two pegs that affix the gear shaft to either side of the motherboard, the aforementioned gear shaft, the bottommost gear that changes the vertical movement of the gear shaft into horizontal movement for the wedge, and one final component that acts as a bottom for the entire gear assembly and acts as guiding rails for the wedge. For those keeping score at home, that's a total of 27 individual parts used to make this monstrosity. Coincidences aside, man, this project took a lot of time to print out. Also, quick side tangent to anyone who wants to incorporate 3D printing into a story. 3D printing takes a bit of time. Unless you state it's a magic 3D printer, or you're in a sci-fi setting where technology is advanced significantly from our own, printing things takes hours, not seconds. To give you some idea of how long it can take, the total amount of time my printer spent making these parts, and that includes parts that weren't up to snuff, is 36 to 48 hours. The technology is slow but steady. I'm sorry about going into this massive tangent, but I saw 3D printing portrayed as something very rapid in this dumb Christmas play I saw years ago shortly after getting my 3D printer, and it wasn't accurate and it's bothered me to this day, and quite frankly, I've needed to get this off my chest for a while. Okay, with that finally out of my system, yes, I did end up having to reprint certain parts a lot because I had to make minor adjustments to them. Some parts with gear teeth on them had teeth that were too short, other parts had gear teeth that were too long, sometimes I'd lift the lid and the wedge wouldn't be pushed forward. Actually, the wedge in general was an incredibly fussy part of this entire project. Like, I legitimately lost count of how many revisions I made to it. Between the gear teeth not being tall enough to fit into the bottom cogwheel of the assembly, the wedge not pushing up the lever that elevates the metal cards as much as I'd like, this thing's been about as temperamental as a chihuahua. And the gear shaft's been a pain in my butt too. But I finally had it at the point where everything looked like it was working out fine. It was pushing forward the wedge consistently, the gears were all moving together, it looked like it was time to push past all my failed attempts and bask in the glory of a finished job. But like I said last time, nothing's ever that simple, is it? For one, while it boasts an impressive volume at nearly 90 cubic inches, the carrying capacity peaks at only 9 cards. Which, given how big this thing is, you'd think that you'd be able to carry more metal cards in it. And on top of that, I didn't even accomplish my goal of achieving the gimmick because, well, look at this. Do you genuinely see any difference in the elevation of these metal cards? I barely do. It also means that the point of the gimmick, the ease it would provide in getting out certain metal cards, is lost. That said, some of you might genuinely still want to print and build this for yourselves, so let me give you a quick tutorial on how to assemble this thing. I may personally feel that this version is a bust, but hey, maybe you'll have better luck getting it to work. Firstly, take the 2 card holders, put the lever that raises up all the metal cards between them, and combine. Congratulations, that was the easy part. Next we'll assemble the gear assembly, and that starts by placing the guiding rail pegs onto the back lid. Both of these guiding rail pegs on the back are identical, so just clone them within your Slicer program. And if you don't know what I mean by Slicer program, go watch my tutorial on how to 3D print stuff. The other square pegs that I use to affix the gears and other moving parts to the inside of the box also come in identical pairs, so once you get the files, just clone them in the Slicer program again. The hole at the top is for the thick, short peg, the hole beneath it is for the thin, short peg, the hole beneath that is for a longer, thinner version of the guiding rail we put on the back, and the hole at the bottom is for a longer peg that's for the bottommost gear, and the circular hole at the top is for the pin that will affix our lid. Next up, we'll need 2 copies of the long tube-shaped gear, and those will go on the first 2 pegs at the top of the assembly. Then take the smaller gear that's shaped like a spool of thread and attach it to the bottommost peg. Next, put the gear shaft into the sliding rails with the larger teeth at the top. We can now attach the back cover to the entire rest of the motherboard assembly, and also attaching the lid to those round pegs at the top that we installed earlier. Assemble all the pegs onto the other motherboard and then push everything together like so until everything snaps into place. Lastly, take the wedge and attach these components to its side that help it slot into the guiding rails. Slide the wedge into the guiding rails on the bottom of the entire gear assembly. Attach the bottom to the rest of the gear assembly like so. Now attach the entire thing to the card slots at the front, and bada bing bada boom, you're done. I'm not gonna lie, I'm extremely disappointed in myself. Like, I know I said last time that I prefer things to be function over form, but yeesh, this is bad. Especially because there are way more gaps and seam lines than I intended there to be. Everything should have fit together perfectly, but it doesn't. Nothing sits flush, it all leaves behind little pockets of air that I can see through, and overall it just looks bad. I know I can do better than this. I have done better than this with that sword that I showed off at the start of this video. But for now, I think I'm just gonna call it quits on this particular project. I'm not gonna give up on the idea of making a metal card holder, especially not when Sam G doesn't seem to be interested in making one of their own. I'm tentatively adding a metal card carrying case to my backlog of projects right alongside my own original metal brace because unfortunately Agabus will not be importing the one from Korea, Mild Metal Cardbot W spoilers in my next project in about 3, 2, 1, and a breastplate for Savinard based off of his original identity, Saber Knight. That said, I'm pretty sure there's at least one person out there who's saying, I could do better than that, and I'm sure you can. And that's why I've publicly posted all the files for version 2.0 on my Thingiverse page, and there's a link in the description of this video to the post. Feel free to modify the files and repost them on Thingiverse, but make sure that you label them as a remix of the original files. But that's about all I have for you in this video. Thanks so much for watching. I hope I'll see you next time, and until then, this is Firebite27 over and out.